So whenever you do an assembly language question, you always get the assembly instruction set with you. One thing before I answer some of these questions with you that I want to really get you to pay close attention to is the order of precedence, okay? What I kind of mean by that is which one is, say, storing the register and which one is reading the register, and vice versa, because sometimes people get that mixed up, all right? So if you look over here, this AND operation, for example, performs a bitwise AND operation between the value stored in register N and the value stored in register D. Okay, so that's one example. It's telling you what, like, one is the first register and one is the second. Okay, so if you put R1 there and R2, vice versa. Now over here, I wanted to bring your attention to this. Add the value specified in the operand to, so that could be a binary number or it could be a hashtag like decimal number. All right, remember, if it's got a hashtag, it's a decimal number, to the value in register N, so that would get added to that and stored in D. Alright, so that's the register used for storing. So you need to pay close attention to which way round, because often when I mark these questions as an examiner, I've seen the students get these the wrong way round, and then it changes your whole outcome of your answer, and I can't really give you much more. So let's have a look at the first question, and I'll flip backwards and forwards. This should be a relatively simple one. So let's just go over here. So figure 1 shows an incomplete assembly program. Incomplete assembly program. The intended purpose of the code is to count from 1 to 10 inclusive, right? So that includes that. Writing the values to memory location 17, which is used to control a motor. Complete the code, all right? Well, what we've got here is, if you look here, move register 0, number 1. So look what move does. Copy the value specified in the operand, which was number 1, all right, into register D. So register 0 is now equal to hashtag 1. That means a decimal number 1, for those of you that are unsure of that, okay? Then, if you look here, it says store. Alright, so let's look at str. Alright, store the value that is in register D. The register goes into the memory location. So this is, can you see how we've gone from one side of the code, right, to the other? So that, first time around, the number 1 is put into register 0. This time, register 0 is going into memory location 17. So that could easily confuse people. So inside register 0 is the number 1, but then inside memory location 17 is also that number now. Okay, so we've got number 1 in register, sorry, we'll just say memory 17. Alright, and I've just realized I'm writing in a red pen. So, alright. Now, what we've got to do each time is we've got to get from 1 to 10 inclusive. So I'm going to need to add number 1 to this number, alright? Notice it's a loop, so you're going to need to use some sort of branch or some sort of thing that says, oh, when I've got to the number 10, but I can't get to that number 10 yet or do that check yet until I add a number to it. So what I'm going to do next is add, alright? And if you look at add, right, register, add the specific value, so I'm going to add 1, right, to the value in register N and store the result in D, alright? So in this case it doesn't really matter because I just want to add it to itself, so I can use R0, and then I'm going to do hashtag 1, alright? Because then what that does, alright, it stores the result here. That's where we're storing the result. That's what we're adding to. So you just got to pay close attention. Now, After that, all right, it's not in, all right, it's not in register. Well, all that would do is add 1, all right, to that value. So that is now 0, is now going to be 1. Yeah, so I've added 1. Sorry, that's going to be 2 now, isn't it? All right. But if I go back up here, that's going to go 3, 4, 5, 6, 7, 8, 9, 10. But it's going to continue. I haven't got something that's going to get me out of this loop now. That's why we use branches in assembly code, okay? But I'm going to need to compare it first. So if the number is 11, I'm going to basically get out of that loop, all right? So what I'm going to say here, so let's look at the comparisons. Compare. So I'm going to compare the value stored in, so that would be R0. I want to check what's in R0, all right? I'm going to check the value in register N with the operand. So I'm going to check whether it's equal to, so whether register is compare R0 with hashtag 11. If that number has got, no, because I'm going to explain in a minute why I've done it this way. There's another way of doing it. All right. If that number is 11, I can pretty much get to halt, because at this point, if it's, so if say for example I got to 9 there, yeah? If I got to 9 there, added 1 to it, that's 10, all right? But it's not 11, so I'll go back around, all right? Yep. But if I add 1 to it, it's not 11, but the value is 10 there, all right? But 10's now been stored into register 17 as it asked. Do you see what I'm getting at? Yeah. All right? So then if I add 1 to it this time, it's going to be 11. So if it's compared to 11, I now need to get out of that. All right? If it's not equal to 11, and I'm going to say match not equal start loop. All right. So what I've done there is I've said if it's not equal to the value I need to, I go back to the start loop. All right. I think that's right. Branch if not equal to. Yeah, if you look here, your branch statements, you got B, all right? But down here, all right, branch to the instruction at that position if the last comparison met the criteria. Possible values, you can have branch equal to, branch not equal to, branch greater than, branch less than. So when it's not equal to, I'm going to go back up to there, but as soon as it's equal to, it's going to finish that. Right? So branch not equal to is going to keep going back up there. Am I making sense of why I would put that there? Yeah? So every time it's not equal to 11, it's going to keep going back up. That's what that's saying. You need to have something that sends it to that for the loop to continue. So if it's not equal to that, so then again, if it is equal to that, then it's going to go to the end loop. It's just going to go to the next set of statements, all right? Would anyone like clarification on that? I know I may have done that in a bit of a roundabout way. Which bit? Just the last line. Well, this bit here? Yeah. Well, look, if I add 1 to that, yeah. All right? Sorry, so I've just, let's work it out as if I'm on number 9 now, yeah? So 9 is currently stored in register 17, yeah? I add 1 to that and store it in R0. So R0 is now equal to 10. Yeah? Right. So you got me. So this, imagine this is 10 at this point. I'm going to compare 10 to 11. All right? Well, 10 is not the same as 11. So I'm going to go back up to start loop. Hence, branch not equal to. So I go back up to start loop. Yeah? This time around, all right, 10 is in register 17 because that's what that line does. It stores the result, yeah? If I add 1 to 10, that is now 11, yeah? So R0 is 11, and I'm comparing it with 11. If it is equal to, it's going to ignore that and then go straight to the next loop, which is halt. Okay, so that's what's happened there. All right, R1 contains the value 7. What value will be contained in R1 after that instruction? So I'm going to write this down here, LSL. R1 stores the value 7. I'm going to put a hashtag 7, but I'm shifting hashtag 7, right, by 2. Your best bet, if I'm honest, to do this is, let's look at the value here, all right, LSL. Logical shift left, the value stored in register N. So the second one is register N, so this value is going to be shifted, all right, by the number of bits expressed by the operand. Well, it's wanted to shift 7 by 2. Now, if you don't know what that is, all right, what the left shift does begins with an M. This is multiplying, so you could actually just work that out, all right. But there's another way of doing it, I suppose. All right, for those of you that are more visual learners, what you might have done is gone 1 1 1 0 0 0. So 1 2 3 4 5 6 7 8. What some people have done is they've just shifted it twice. All right, so they may have done that left shift, but 2. All right, now becomes 0 0 1 1 1 0 0. So 1 2 4 8 16 16 plus 8 plus 4. This is a long way of doing it, but I'm just trying to help you understand what's happened. All right, 16 plus 8 plus 4 equals to 28, and there's your value there. All right, does that make sense how the left shift works? Which would have got you, because you would have multiplied it by 2, which would have got you 14. Then times it by 2 again, it would have got you 28. All right? Don't make the mistake of thinking, oh, left shift 2, I'm going to multiply it by 2. Yeah? Because each shift is a multiplication of 2. You've got to remember that. All right? I'm going to not record that bit anymore. I'm just going to pause that, so that's one video.